Welcome to A-Level and AP Physics. In today's lesson, we will discuss one very important and typical type of question on gravitational field from May-June 2021 paper 41. This question is very important because you will see the same type of questions in many past papers. For this question, it is given to us the Earth may be assumed to be an isolated uniform sphere and the mass of the Earth is given. It is also given to us we can assume that the mass is concentrated at its center. A satellite of mass 1200 kg is in a circular orbit about the Earth in the Earth's gravitational field. The period of the orbit is given, that is equal to 94 minutes. For part A, simply we need to define gravitational field. Part A is simply asking us how strong is the gravitational field. I mean, how we can define that, how strong is a gravitational field. In order to understand that, simply we can sketch this one small sphere. Let's say this is our planet. And there is a unit mass, means the mass of this object is 1 kg. We can simply write down the mass of this one is 1 kg. Now gravitational field simply is telling it how much force is acting on this unit mass, and that is the gravitational field. Means we can find out how strong is the gravitational field. We can also write down the small g is equal to F over small m, force per unit mass. So simply we need to write down here force per unit mass. So that's all what you need to write down for 1 mark. If you write down force per unit mass, you will get 1 mark. And this is B mark for this question. This is B mark, means you have to mention this one in your answer. So this is B mark, you will get 1 mark. For part B, we need to calculate the radius of the orbit of the satellite. So it's a great way to sketch first of all, so we can see the clear picture of this question. Let's say this is our planet and its mass is capital M, and satellite is orbiting around our planet, and let's say the mass of satellite is small m. This satellite is orbiting in a circular orbit around our planet. So this is the orbit. The question is asking us to calculate the radius of the orbit. Radius of the orbit means that this is the distance between the centers of these two bodies. Let's say the distance is equal to small r, and this is the radius of the orbit. This is what we need to calculate. Question is asking us to calculate the value of this radius. Now we need to understand, as this satellite is moving in a circular orbit and it is accelerating, because its velocity means its direction is changing all the time, so it is accelerating. If a body is accelerating, it means there is a resultant force, and in this case the resultant force is provided by the gravitational force between these two bodies. So we can simply write down the gravitational force is providing the centripetal force, provides the centripetal force. But you cannot say gravitational force is equal to centripetal force. Centripetal force is just fancy name for resultant force, and it is not a force by itself. In this case, gravitational force is providing the centripetal force. Now we need to understand, according to Newton's law of gravitation, gravitational force is equal to G capital M small m divided by the distance between centers of two bodies square, and centripetal force is equal to mv squared divided by the distance between centers of two bodies. And so they are the same. If you look at this one, the mass of satellite, we can cancel on both sides, and r we can also cancel. So here we left with G capital M, and this is equal to v square, and v is the orbital speed. Orbital speed v, this is also equal to 2 pi r, means the total distance travel in one cycle divided by the time taken, means this is the time period. We need to plug in values of v square, so we can write down this one here now. This is G capital M over r, and here we can write down this is 4 pi square r squared divided by t squared. Because this is v squared, so I just directly plug in these values. So this is v squared. Now we need to rearrange this one for r. So if we cross multiply, we can write down this is 4 pi square r cube, that is equal to g capital M t square. We need r, so we can rewrite here r is equal to g capital M t squared. This is the time period divided by 4 pi square. We need r, so we need here the power of this side. This is 1 by 3. Now simply plug in values, we can find out value of r. G, this is constant and its value is given in data, means the value of g you can find in data. If you just check the first page, you can find out the value of data it is given. Its value is 6.67 times 10 to negative 11. This is constant. If you remember, that's wonderful. If you didn't remember, you can just go to data page and you can find its value. M is the mass of the planet, is capital M. The mass is given, that is 6.0 times 10 to 24. And the time period, this is given in minutes. We have to convert into seconds. We can write down 94 times 60, and this is t squared, so this is square, divided by 4 pi squared. So you can plug in value of pi, and we have to take the cube root of this 1 by 3. If we solve this one, we will get our final answer, that will be 6.9 times 10 to 6 meters, up to 2 SF, and that's the answer. This is how you need to do. This question is very common. Try to understand. Always start with this. Gravitational force provides the centripetal force. Then write down the formula, then rearrange the equation, then find out what you need to calculate. This question has 3 marks. Let me explain to you how these marks will be awarded for this question. You will get the first C1 mark if you have equated gravitational force and the centripetal force. You will get first C mark. And the second C mark you will get if you have substituted the values. And the last mark is answer mark, and this is for correct answer. If you got correct answer, you will get this 3rd mark. For part C, it is given to us rockets on the satellites are fired so that the satellites enters a different circular orbit that has a period of 150 minutes. The change in the mass of the satellites may be assumed to be negligible, means there is no change in the mass of the satellite. For C1, we need to show that the radius of the new orbit is equal to this. In order to calculate the radius of the new orbit, we need the expression from part B. In part B, we have derived that gmt square over 4 pi square, this is equal to r cube. R is the radius of the orbit. Let's divide this one first of all by t square on both sides. If we divide by t square on both sides, we can cancel this t square with this one. Then we simply left with gm over 4 pi square, and this is equal to r cube by t square. If you look at left side, here g is a constant, m is the mass of the planet, that is also constant, and pi is also constant. So simply we can write down r cube divided by t square. This is constant, means the ratio between these two quantities r cube and t square is constant. So we can also write down r1 cube over t1 square is equal to r2 cube over t2 square. T2 means this one is for the new orbit. So this is what we need to calculate. We need to calculate the value of R2. You can also understand like this. Let's say this is our planet. Its mass is capital M. We have one satellite, means the satellite, in this case we have just one satellite. First of all, satellite was at point A. Then the satellite moved to point B. In this case, the ratio between the radius, here this one we are saying is, this is R1, this radius is R1, and the time period in this orbit is T1. Now the new radius is R2, this is the new radius. This is what question is asking us to calculate. Radius of new orbit, and it has to be equal to this one. We need to show that it is equal to this. And the time period for the new orbit is given T2. We have the value of T2. So this is T2. So simply we need to find R2. We can rearrange, we can write down R2. This is equal to R1 cube times T2 squared divided by T1 squared, and we need to take the cube root of this, means 1 by 3. Now we just need to plug in values. R1 in the previous part we have calculated, that was 6.9 times 10 to 6. Cube of this multiply with the time period, means T2. Value of T2 is 150 minutes. We need to multiply by 60. Square of this divided by T1. T1 in part B it was given, that was 94 minutes. So again we need to multiply by 60. Square of that. Then we need to take the cube root of this. If we take the cube root, our final answer will be equal to 9.4 times 10 to 6 meters. And this is what we need to show, that the radius of the new orbit is equal to 9.4 times 10 to 6 meters. This question has 2 marks. The first mark is C mark. You will get first mark if you have written this expression. And the second mark is answer mark. You will get the second mark if you have got the right answer. Let's move on to part C2 now. For C2, we need to state with a reason, means state, and we have to write a reason whether the gravitational potential energy of the satellite increases or decreases. First of all, let's look at this point. When the satellite was at this point, let's say the potential energy of the satellite, that is EPA. And when the satellite was at this point, let's say the potential energy, gravitational potential energy of the satellite is EPB. Now we need to explain, is the potential energy EPB is greater or EPA is greater? For that purpose, we need to understand the gravitational potential energy. Gravitational potential energy is simply is equal to G capital M small m divided by R, and R is the distance from the center. If R is greater, EP will be greater. The reason is that because if R is greater, this will be less negative. When this is less negative, it means EP is greater. EP is 0 at infinity. If we look at EPB, this is less negative. This is less negative value as compared with EPA. This is more negative. So we can simply write down this one is more negative. It simply means that in this case, EPB means the gravitational potential energy of the satellite at B is greater than gravitational potential energy of the satellite at A. Because R is greater, if R is greater, it means gravitational potential energy is less negative. So that's the reason. First thing you need to write down increases. We can simply write down gravitational potential energy increases. Second, we need to explain why increases. We can simply write down the reason is that because the separation increases. We can write down separation increases, or you can say the distance from the center of the planet increases. And this question has only 1 mark, and that mark is B mark. For this part, we need to determine the magnitude of the change in the gravitational potential energy of the satellite. First of all, let's try to understand this with the help of one sketch. Let's say this is our planet and its mass is capital M. Satellite was at the beginning at point A, then satellite moved to point B. When the satellite was at point A, let's say the radius of the satellite was R1. And when satellite moved to point B, let's say the radius of the satellite, this is R2. We can also assume that the gravitational potential energy of the satellite when it was point A, let's say this is GPA A, and when the satellite is at point B, its GPE, gravitational potential energy, is GPE sub B. Question is asking us for the magnitude of the change. It simply means the change in gravitational potential energy, GPE, that is equal to gravitational potential energy of the satellite at point B potential energy at point B is greater minus gravitational potential energy of the satellite when it was at position A. Now we also need to understand GPE. This is equal to negative G capital M. This is the mass of the planet, and small m, this is the mass of the satellite, divided by the radius of the orbit. This is R2. When it was at position A, the radius of the orbit is R1. We need to write down this negative sign is very important. This is divided by R1. Now you can see here, if we multiply with negative sign inside, we can write down G capital M small m. Here we multiply, so this will be plus G capital M small m over R1. Now from here we can take G capital M small m, we can take common, then we can write down this is 1 over R1 minus 1 over R2. Now simply we need to plug in values of G, capital M, small m, R1 and R2. Capital G, this is 6.67 times 10 to negative 11, and the mass of our planet is 6.0 times 10 to 24. Mass of satellite is 1200 kgs, and the radius of the orbit when the satellite was at point R1, we have that was equal to 6.9 times 10 to 6. When it was at point B, we have calculated that was 9.4 times 10 to 6. Now simply we need to calculate. If we calculate this one, our final answer will be 1.9 times 10 to 10 joules, and that's the answer. That is the change in gravitational potential energy of the satellite when it moved from point A to point B. Let me explain to you how marks will be awarded for this question. This question has 3 marks. The first mark is if you have written these formulae, you will get first mark. If you have written the formula for gravitational potential energy, this is C mark, first mark. And the second mark you will get if you have substituted these values, you will get second C mark. And the last mark is answer mark. If you have got the right answer, correct answer, you will get the last mark. If your answer is not right, but you have written these steps, means you have written this formula, you have plugged in values, you will get 2 marks. So it's good to write down all the steps and show your working. Welcome to A-Level and AP Physics. In this lesson, we will discuss a kind of typical question on thermal physics from May-June 2021 paper 41. For this question, it is given to us an ideal gas is contained in a cylinder by means of a movable frictionless piston as illustrated in figure 2.1. So this is figure 2.1 and this one is piston, and this piston is frictionless. It simply means that there is no friction between the piston and walls of the cylinder. This is our cylinder, these are the walls of the cylinder, so there is no friction between walls of the cylinder and piston. This is what is given to us. It is also given to us initially the gas has volume of 1.8 times 10 to negative 3 meter cube, and the pressure of the gas is also given, temperature of the gas is also given, and this is in kelvins. For part A, we need to show that number of gas molecules in the cylinder is equal to this. In this question, we are talking about ideal gas. It simply means that we can use all ideal gas laws, and also we can use the general gas equation for ideal gases. First of all, let me explain to you the general equation for ideal gases. PV is equal to nRT. Here n is the number of moles. This is number of moles. This small n, this is number of moles. R is gas constant, T is temperature, P is pressure, and V is the volume. We can also write down this one in a little different form. We can write down PV is equal to NKT. N here is number of gas molecules. So this is equal to number of molecules. K is Boltzmann constant, and the value of Boltzmann constant is 1.38 times 10 to -23. This is the value, and you can find out this value in data. In data list, you can find out this one. This is given. You don't need to remember this one. This is given in data. Now simply we need to use this equation and we can calculate number of gas molecules. Simply you can write down N is equal to PV divided by KT. Value of P is given, and this is 3.3 times 10 to 5 Pascal, and the volume is given, that is 1.8 times 10 to -3 meter cube, and the K is a constant. This is Boltzmann constant. We can write down its value, and this is equal to this one, and the temperature is given. This is in Kelvin. It has to be in Kelvin. So if temperature is given in degrees Celsius, you need to convert into Kelvin. So we can write down into Kelvin. If we solve this one, our final answer will be 1.4 times 10 to 23, and this is the number of molecules. If you prefer to use this equation, you simply need to understand N is equal to number of molecules over Avogadro's number. So first you will calculate number of moles, and then you can find out number of gas molecules simply by multiplying number of moles with Avogadro's number. Then you have to use this one. So this will be two step. If you use simply PV is equal to capital NKT, this is just one step. This question has 2 marks. If you have written this formula, you will get 1 mark, means C1. You will get 1 mark. If you have got the right answer, you will also get the answer mark. So there are 2 marks for this question. First mark is for writing the formula, and the second mark is for correct answer. If you have got the correct answer, even you didn't write formula, you will get 2 marks. But if you have written the formula but you got wrong answer, still you will get 1 mark. So it's very important to write down the formula, then plug in values, and then do calculations. For part B, it is given to us, we need to use kinetic theory to explain why when the piston is moved, the gas expands. This causes a decrease in the temperature of the gas. For this question, it is given to us the gas expand. It simply means that the work is done by gas, and work done by gas is equal to change in kinetic energy of the piston. So we can simply write down work done by gas is equal to change in kinetic energy of the piston. It simply means that gas is losing energy and the piston is gaining energy. As the gas is losing energy, it also means that the kinetic energy of gas molecules decreases. As the kinetic energy of gas molecules decreases, it also means that the mean square speed also decreases. Now we need to understand how the kinetic energy of gas molecules is linked with temperature of the gas. First thing, we need to understand the average kinetic energy of gas molecules. This is equal to 1/2 m times mean square speed, and this is the mean square speed, and this is also linked with temperature by 3/2 kT. Now from here, this is the average kinetic energy of gas molecule. From here you can see, as the kinetic energy is decreasing, it also means that the mean square speed is decreasing. As the mean square speed is decreasing, it also means that temperature of the gas is decreasing. So this is what is happening, and this is all what you need to understand. This question has 3 marks, so you need to write down the 3 points. Let me explain to you now how you can write a proper answer. So here is the answer. This is how you need to write down. First thing, if you have mentioned in your answer the speed of molecules decreases on impact with moving piston. Otherwise you can also say that work done by gas is equal to change in kinetic energy of the piston. So the gas is losing energy. You can also write down in this way, and this is B mark. You will get 1 mark. The second, if you have mentioned the mean square speed is proportional to kinetic energy of molecules, you will get the 2nd mark. As you can see here, this one is the mean square speed, and this is proportional to kinetic energy because mass of molecule is not changing. The third point you need to mention, kinetic energy of molecules decreases, so temperature decreases. You can also see from here, if the kinetic energy of molecules decreases, temperature also decreases. That's all what you need to write down, and this is how marks will be awarded. For part C, it is given to us the gas expands, so its volume increases to this one and its pressure decreases to this. Also, its temperature decreases to 288 Kelvin. It is also given to us the average translational kinetic energy of a molecule, very important. So this is for a molecule of an ideal gas, means if you need to calculate the kinetic energy of a molecule of an ideal gas, simply we can use this equation. In this equation, it is given to us K is the Boltzmann constant and T is the thermodynamic temperature. Thermodynamic temperature means that the unit for temperature we need to use, it must be Kelvin. Question is asking us, we need to calculate the increase in internal energy of the gas during the expansion. For this question, we need to calculate the increase in internal energy for an ideal gas, and for an ideal gas, the change in internal energy is equal to change in kinetic energy of the molecules. We need to calculate the total increase in internal energy. It also means that we need to calculate the total increase in kinetic energy, or simply we can say the change in kinetic energy. In order to calculate the kinetic energy of a molecule, we have this equation that is 3 by 2 K times delta T. This is for one molecule, but in the gas, let's say we have n number of molecules, so we need to multiply with n number of molecules, and we have already calculated in part A. Now simply we need to plug in values and we can find out the change in internal energy for an ideal gas. Simply we need to plug in values now. So this is 3 by 2 and K is Boltzmann constant, and the value of Boltzmann constant is 1.38 times 10 to negative 23 joules per Kelvin. We don't need to write unit here right now. Temperature must be in Kelvin. Temperature, initial temperature is 310, but the final temperature is 288. So we can write down 288 minus initial temperature. We need to multiply with number of molecules. Number of molecules we have already calculated in the previous part, and our answer for part A was that is equal to 1.4 times 10 to 23. Now we just need to multiply all and we can calculate the change in internal energy. In this case, our final answer will be minus 64 joules. It means kinetic energy of molecules, or we can say simply say kinetic energy of the gas decreases. This question has 3 marks. Let me explain to you how these marks will be awarded. The first mark will be awarded if you have written this formula. You will get first C mark, and the second C mark you will get if you have plugged in these values, and the third is answer mark you will get if you have got the right answer. But if you have got the right answer and you didn't write these steps in this way, still you will get 3 marks. But if your answer is wrong but you have written these steps, you will get 2 marks, means 2 C marks you will still get even your answer is wrong. So it's very important to write down formula and plug in values. For this part, it is given to us the work done by the gas during the expansion is 76 joules. We need to use our answer in 1 and we need to explain that whether thermal energy is transferred to the gas or the thermal energy is transferred from the gas during the expansion. In order to answer this question, we need to apply first law of thermodynamics. According to first law of thermodynamics, delta U means the change in internal energy. This is equal to Q plus W. Q is the amount of thermal energy and W is the amount of work done. Amount of work done means the work done can be positive, work done can be negative. Work done is positive if the work is done on gas. So that is positive. It simply means that energy has been transferred to the gas. If the work is done by gas, means the gas expand. It means gas is losing energy. If the gas lose energy, work done by gas is negative. We also need to understand when Q is positive and when Q is negative. If thermal energy is added to the system, if the thermal energy has been added to the system, so the Q is positive. I will simply write down, if the thermal energy is added to the system, Q will be positive. If the thermal energy has been removed from the system, then Q will be negative. Means thermal energy lost. Thermal energy lost, we can say, the thermal energy is transferred to the surrounding from the gas. We can also say the thermal energy is transferred to the surrounding. So let me clean and rewrite again. If the thermal energy is transferred to the surroundings, it means the thermal energy is lost. If the thermal energy is transferred to the surrounding from the gas, then in that case Q is negative. That's all what we need to understand. For this question, we have already calculated delta U is equal to minus 64 and Q we need to calculate, and W is the work done by gas. Very important. Work is done by gas. It simply means this is negative. From here, we can calculate the value of Q. Q will be equal to 12 joules, and this is positive. So if this is positive, it simply means that energy has been transferred to the gas. Let's try to understand how we can write a proper answer for this question. In order to get 2 marks, the total marks for this question are 2. You need to write down, first of all, decrease in internal energy is less than work done by the gas. As you can see here, the decrease in internal energy, this is equal to minus 64, but the work done by gas, this is minus 76. It simply means that thermal energy has been transferred to the system, means it has been transferred to the gas. So that's the reason we got answer. This is plus 12. This is telling us thermal energy has been transferred to the system, or we can say thermal energy has been added, as I explained here. If it is positive, it means thermal energy has been added to the system. So this is one point you need to write down, and this is the M mark. It means that it must be in your answer. And the second mark is answer mark. If in your answer you have written that thermal energy is transferred to the gas, you must write down to here, not from. If you write here from, it means you will not get this mark. So 2 has to be in your answer. So this is underlined. It must be in your answer. Welcome to A-Level and AP Physics. In today's lesson, we will discuss important past paper question from May-June 2021 Paper 41. And today's question is about simple harmonic motion. For part A, we need to state what is meant by simple harmonic motion. This is very basic question, but it is most frequently asked question in past papers. Almost every year, you will see they will ask you state what is meant by simple harmonic motion. So we need to be very clear about this one, how we can state simple harmonic motion. Sometimes this question has 2 marks, sometimes this question has 3 marks. Let's try to understand what is meant by simple harmonic motion. In order to understand simple harmonic motion, we need general equation. Let me write down here first of all the general equation for simple harmonic motion. General equation. A is equal to minus omega square x. A here is for acceleration, so we can write down A here is for acceleration. Omega is the angular frequency, so we can write down this is angular frequency. X is the displacement, so this is displacement. We also need to understand what is meaning of this negative sign. Omega for simple harmonic motion, omega is constant, so we can also write down this is constant. If omega is constant, then simply we can say A is directly proportional to minus x, negative x. As A is directly proportional to negative x, it means that as A increase, we can break down this one into two parts. We can write down A is directly proportional to x. It simply means that when the x is increasing, A is also increasing. The second point we can write down the meaning of negative sign. Sometimes in exam they will ask you what is significance of this minus sign. Significance. So that is very important question. 2 marks question, 1 mark question, they can ask you significance of minus sign. So this is very important point. You need to understand what is significance of this sign and what this sign is telling us. This sign is simply telling us the significance of negative sign. We can draw one small table. Let's say this is over A and let's say this is over X. Negative simply means that when X is negative, A is positive. And when X is positive, A is negative. Let's try to understand what this table is telling us now. According to this table, we have written when X is negative, A is positive. When X is positive, A is negative. What exactly it means? It simply means that acceleration is in opposite direction to displacement. Now we understand what is general equation for simple harmonic motion and how to state simple harmonic motion. We also understand what is significance of this negative sign. Let's try to state what is meant by simple harmonic motion, or simply we can say let's try to write down answer for this question. This question has 2 marks. In exam, if you write down acceleration of the body is directly proportional to its displacement, you will get 1 B mark. If you write down acceleration is in opposite direction to displacement, you will get second B mark, means you will get 2 marks, and the total marks for this question are 2 marks. If this question has 3 marks, then you also need to mention acceleration is always directed towards that fixed point. So you will get another B mark. So you will get 3 marks. But this question is only for 2 marks. If you have written this point and you have written this point, you will get 2 B marks. For part B, a spring mass system is given. As you can see in this figure 3.1, one oscillator is attached at this point. So this is our oscillator. So this one is oscillator. Then a spring is attached. This spring is attached with oscillator and trolley. After trolley, this one is the trolley, and after trolley there is another spring, and this spring is attached with trolley and it is also attached with the fixed point. So this is the fixed point. As you can see, it is given in the question, attached to a fixed point P, means it cannot move. For this question, it is also given the spring constant is 130 newtons per meter, and mass of the trolley is also given. The mass of the trolley is here. It is also given oscillations of the trolley are simple harmonic motion. We can also find the acceleration A of the trolley by this expression. So here is A and this is X and this is omega squared. So this part is omega squared. So A is equal to minus 2k by m times x. For this question, we need to calculate the frequency of oscillation of the trolley. X is the displacement of the trolley from its equilibrium position. In order to calculate the frequency, we need to compare this given equation with general equation of simple harmonic motion. So let me write down here general equation of simple harmonic motion. Now if you look at these two equations, we can simply find out that omega square here is equal to 2k by m. So simply we can write down here, from here omega square, this is equal to 2k by m. 2k by m omega square, but we need to find the frequency. So we need to understand omega, this is also equal to 2 pi f. So this is, we can replace omega with 2 pi f because we need to find the frequency. So we can plug in value of omega. So omega is 2 pi f square. This is equal to 2k by m. We need to find out value of f. We can write down first of all, this is 4 pi square and this is f square. This is equal to 2k by m. We need value of frequency, so simply we can rearrange. So this is 2k divided by 4 pi square m, square root of this. Now simply you need to plug in values. K is given, the value of K is 130 newtons per meter. For pi square, we can plug in value of pi. We need to multiply with mass, but mass is given in grams. If we convert this one into kilograms, we need to divide by 1000, so this will be equal to 0.84 kg. We can write down here, this is 0.84 kg. We need to take the root of this. If we solve this, our value of frequency will be equal to 2.8 hertz. And that's the final answer. This is, we can write down here. Let's try to understand how marks are distributed for this question. If you have written omega square is equal to 2k over m, for this expression you will get first C1 mark. The second C1 mark is if you have written frequency in terms of k and m and you have plug in values, you will get the second C1 mark. And the third mark is for answer, means A mark, and that one you will get if you have got the correct answer, means your frequency is equal to 2.8 hertz, so you will get A mark. This is how marks are distributed: 2 C marks and 1 A mark for the correct answer. Even if your method is different but you got the correct answer, still you will get 3 marks for this question. For part C, it is given to us the amplitude is a maximum at the frequency calculated in B. In part B, we have calculated frequency that was equal to 2.8 hertz. Now we need to understand amplitude is maximum. When the amplitude is maximum, it simply means that system is absorbing the maximum possible energy. Simply we can write down the system is absorbing the maximum possible energy. So I will simply write down energy maximum is absorbing the maximum possible energy, and this will only happen if the driving frequency, in this case the frequency of oscillator, if it is equal to the natural frequency f0 of the system, then system is able to absorb the maximum possible energy. If this is happening, then amplitude also will be maximum. Question is asking us state the name of this phenomenon, and that phenomenon simply we call is resonance. So for this question you need to write down resonance. This question has only 1 mark and this is B mark, means you must write down here resonance, because this marks is independent and it must be seen in your answer. If you simply write down resonance, you will get this B mark, you will get 1 mark. For part C2, it is given to us at any given frequency, amplitude of oscillation of the trolley is constant. We need to explain how this indicates that there are resistive forces opposing the motion of the trolley. First thing we need to understand is amplitude of the trolley, oscillations of the trolley is constant. It means that energy of trolley and spring system, that is constant, so energy of the system is constant, but oscillator is providing energy continuously to the system, but energy of the system is not changing. So what exactly it means? It simply means that energy has been transferred into any other form or work is done against resistive forces. That's the reason energy of the system is not changing. System is not absorbing energy, but energy supplied by oscillator is doing work against resistive forces. Let me explain to you how you can write a proper answer for this question. This is how you can write down a proper answer. First point, you need to write down oscillator supplies energy continuously. This is very important, and this is B mark. it must be in your answer, so this is very important. You have to mention that. Second part, energy of trolley is constant, so energy must be dissipated. This is also B mark, so this also has to be in your answer. If you write down these 2 points, you will get 2 marks.